My dear J26 and 2027 students, welcome to the class 11 syllabus, and we are doing the units, dimensions and measurements chapter, and we are on to the measuring instruments. That's the Vernier Caliper and Micrometer screw gauge. And the best part about today's class, we are going to see this particular micrometer screw gauge. Yes, this is a measuring device along with the Vernier Caliper live in action and how it really works and the theory behind it, and of course the PYQs. So I'm pretty sure you're all excited for this session. Quickly go ahead and smash that like button. In case you have forgotten to do so, do that right now and subscribe to the #1 J English channel in the country. That is your very own Vedantu J English. And if you want to see any of the previous classes, it's there live on the channel. Well, 12 standard classes at 8 o'clock, 11 standard classes at 6 o'clock. Yes, that's the usual time, my dear students. So this was our previous class where we did a lot of things on, okay, let me just go back over here. Yes, a lot of things on errors and its combination. And as usual, I give you homework questions, etc. Quickly smash that like button. You guys are very lazy. You need to be spoon fed out here. Yeah, smash that like button and answer in the comment section. The PDFs, everything come up in the comments along with the description box. Okay, I want everybody to answer it. Yes, very good, Sulochana. Very good, Shravya. You deserve a like and kudos. See, many people are already becoming inconsistent. You cannot fall back behind. You maintain your rhythm and momentum. Okay? Keep solving the homework questions. Yes, even if somebody has solved, it doesn't matter. Post it. That becomes a habit. And before you realize, you're already a step ahead of others. Right? Hi, Aradhya. Hi, Rutveshwaran. Tharuna. Welcome. Hi, Abhi. Welcome, Hars. Hi, Abhijit. Nice to see all of you. Well, I think I should make separate videos for 9th and 10th standard students very soon. Hi, Red Dragon, Zoya, A. Mitra, Sai. Welcome, Joy. Welcome, welcome, everyone. So, let's begin with the class. And let's also take a moment to congratulate all our toppers. Yes, this was the ISI exam. It is tougher than JEE Advance. And these students believed in us, stayed with us, prepared with us online, just followed what the teachers said. They did not join any other coaching, completely prepared online, and All India Rank 1 in ISI. This is a mathematical institute, just like you might have heard about CMI Chennai, right? Same way, it's one of the toughest examinations. Barely they solved 6 questions. Hardly any questions are there in the exam. And even if you solve 2 questions, it is considered that you are genius. You qualify for ISI exam. So these students solved 5, 6 questions. That means incredible mathematical power, guys. Kudos to all of them. Last year also we had All India Rank 1. And this year, All India Rank 15 in JEE Advance with full score in mathematics, along with our KCT toppers and board toppers, as well as respective CET entrance toppers. Everywhere we are making sure that Har Ghar Vedantu, meaning every home Vedantu, is becoming a reality. That too studying online. So you should be super duper proud of your seniors. So now it's your turn, juniors, to make sure that you carry forward that torch and beat their results. Yeah. All India rank 15, you should get All India rank 14, 13, 12, 1. Why not? That is completely up to you at the end of the day, right? Okay, definitely. I will make a video, Abhijit. Hi, Shravya. Welcome. Hi, Aradhya. Good evening. Good evening. So, let's understand, first of all, we all have studied a regular meter scale, which is your pocket scale or a long scale or a ruler, what you generally call, or a measuring tape. That is called as a meter scale. And a meter scale typically looks like this. It could be a tape, it could be a small pocket scale, or a long scale made of steel or wood. So usually, if we use our metric system, you will see that the least count, that the least count, that the least count is basically 1 millimeter typically, and it is nothing but 0.1 centimeter, which is as good as saying 10 to the power minus 3 meters. That is the smallest division that you can make, and smallest measurement also that you can make. So somebody can measure the length to be, for example, say 7 millimeters. That is perfectly fine. Somebody can measure the length to be 8.6 centimeters. This is also fine. Somebody can say the length is, 0.2 centimeters. This is also fine. But what is not fine is this. Somebody is saying that the length is 0.23 centimeters. How did we go to the next decimal? Because the smallest length that you can measure is zero point 0.1. So this is 100% not possible using a meter scale. Or somebody else saying the length that I measured is 7.5 millimeters. This is also not allowed because the smallest division is a millimeter. So you can't go below a millimeter. So this is also not possible using a regular meter scale because the smallest division on it is itself a millimeter. So this has decent accuracy till a millimeter, but let's say I want to measure the thickness of my hair or the thickness of a page, or there is a fossil, I want to measure its thickness, or some sheet, some paper, whatever. So I cannot say, okay, I'm just going to make an approximate guess. I think it is half of it, it is 2/5 of it. We cannot make guesses. So we need a device which is more precise and accurate than a regular scale. So that is why we have the vernier caliper, and this is a vernier caliper and a micrometer screw gauge. So you might have seen this in the laboratory, or if you're a 11th standard student, you will soon see it when your classes begin in your school or college. How many of you have seen it quickly? Let me know in the chat box by putting up a thumbs up or a fire emoji somewhere, maybe in the lab, maybe in your dad's engineering office. I don't know, somewhere. Have you seen it? Well, if you have seen it, kudos, guys. So now you are going to learn how it works. It's a beautiful principle on which it works. Okay. And this is decent accurate. This is even more accurate, right? The least count is even less for this. So for very thin small objects you use micrometer screw gauge. For decently thin you use vernier caliper. But if things are in few millimeters, then you will use a normal meter scale. So this has a least count usually typically of 0.1 millimeter. Guess what? Yeah, 0.1 millimeter. For a meter scale, it is 1 millimeter. For vernier caliper, it is 0.1 of a millimeter. But for a micrometer screw gauge, typically it is 0.01 millimeters. Yes, 0.01 millimeters. That's how accurate you can make the measurements, and very, very small. Is that right? 0.01 millimeters is very, very small millimeters. So this can be used for checking whether you have machined a proper axle, or whether we want a part to be fit. Is it made proper or not? So you can use a micrometer screw gauge to check how well it has been manufactured or machined. So most of your car parts usually are checked with a micrometer screw gauge. So if it is a costly car, right? So that's when they use they use micrometer screw gauge, or even something even more than that. But if it is okay, I'm like, yeah, I'm fine, but I want it to be accurate, maybe not so cost effective, then you can go with a vernier caliper, right? So that's how it is. Atomic scale measurements are never done with a typical scale like this. You cannot measure atoms, molecules with these. You use light diffraction methods and interference methods to measure intermolecular distances. So they happen with a very different technique altogether. We cannot use, oh, you are an atom here, okay, I will move the scale, and oh, you are the next atom. We cannot do that. It is very complex, but it's something what you will have a brief idea about in the chapter of wave optics of 12th standard. Okay, so you use light for that. All right. Yes, Meet, we are teaching everything. Oh, you're seen in school lab, physics lab. Awesome, Shravya, precious. Great. Oh, ordered HC Verma arriving on Sunday. That's the best gift you can gift yourself at 9th standard. Trust me, I can already see Abhijit. If you maintain that consistency, I'm pretty sure you will be doing really well. I'm not saying all India rank 1. That is irrelevant. Don't aim for all India rank 1. Just aim for mastering the subject. Okay, all India rank 1, 2, 3 doesn't matter. Just aim for the subject. Trust me, you will be doing really well. Okay, fine. So let's talk about Vernier caliper. Like I said, it looks like this. Now, the special thing about Vernier calipers and micrometer screw gauge is the fact that there is not one scale, but there are two scales in it. So usually in this scale, what happens? You directly take the measurement, right? But in these type of instruments, there are two measurements that you need to do. Yes, one is your regular main scale. You can see this looks like your normal scale. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that is like your normal scale. Same thing with even micrometer screw gauge. You will see that it will have a normal scale, which is always called as the main scale. Same thing over here. You can see this is like your normal scale. I can zoom onto it. Yeah, this is like your regular scale. But on the side, there is another scale, auxiliary scale, supplementary scale, that depends on whether it is vernier or micrometer. This secondary scale here, you can see 0, 2, 4, 6, 8, 10. That is called vernier scale in this case. But for micrometer screw gauge, you can see some numbers written over here, 0, 5, 10, 15. Are you able to see that? If you want, I may zoom it for you. I'll zoom it for you. See this. This numbers 35, 40, 10. Yeah, everybody is able to see. Give me a thumbs up, guys. Is the visuals very clear? Or just shift to a higher quality, 720p. Okay, check your video settings, make it 720p at least, so you can see it properly. Today, a lot of divisions and all of that are there, so I want you to see it properly. So this is your circular scale. This is in a circle, right? It is in a circle. That is why it is called circular scale. This is main scale. So you have a main scale and the second scale. If it is a micrometer screw gauge, it is a circular scale. Whereas for a vernier caliper, again, you have a main scale, your regular scale, just like this, a regular scale. On that, you have an attached secondary scale, which is called as vernier scale. Understood till this point? Yeah. Perfecto. Okay, sir. Yes, I understood till this point, sir. What is the meaning of, main scale and vernier scale? Now, as you can see, there are jaws over here and over here. So what happens is when you move this left or right, this jaw will open up or close. Same thing, this will open up or close. And then you can use this for measuring somebody's thickness or somebody's inner diameter. Imagine, I don't have a hollow thing, but just visualize. Okay, I'm just using our Tattva books. Imagine I make it into a cylinder. I want to measure the inner thickness. I want to measure the inner thickness. And I also want to measure outer thickness. So if I want to measure outer thickness, what I will do, I will open this up and I will place that object here and I will push it. And then the moment the jaws touch the object, that's it. I will make the measurement. Are you able to understand? So right now, there is nothing in between. I'll place my object. If the object is like this, I can put it like this and I will take it till here. Okay, now I'll make the measurement. If it is like this, I will make the measurement like this. I hope this is absolutely clear. I'm just checking myself out on the camera how I'm looking and if the object held is proper, because there might be some parallax. Okay. Similarly, if I want to measure the inner diameter, then what I will do, this hole which is there, I will place it here, guys. You can see this flat edge and this flat edge, they will be over here. They will perfectly match. When nothing is being measured, it is showing 0, 0 only. If I put it here and I move it like this, zoop. So till those jaws touch the inner edges or the inner parts, I will expand it and then I will make the reading. Is this clear? So you can measure outer diameters or outer widths or the hollow tube or a hole's inner width also using a vernier caliper. How many of you are able to visualize this? Right now, nothing is measured. The moment I put this, I can just move it till it, touches the inner widths or the inner parts. And then I can make the measurements. How to do the measurements? We'll come to that. Yep. All right. Perfect. Thank you so much, Abhijit. My representation is awesome. Kanpur, because of me, I got into IIT. I'm so glad, Kanpur. And it would be splendid if you could tell your name, rank, and which branch you are expecting, etc. And how were you associated with our YouTube or any of the batches, right? Okay. Now that we understood, okay, we have a main scale. This is our main scale. This one is our vernier scale. This particular part is useful. This particular part is useful for measuring inner width, and this particular is usually used for measuring your width outer width. This is again called as the jaws, of the vernier caliper. Okay, these screws can be used so that if it is sliding very smoothly, then you just tighten that screw so that it does not slide. Okay, because you can see if I just move it, it is sliding. So if I tighten this screw, then it will not slide. The measurement is fixed. I can take it as it is, and I can see if other parts are also of the same diameter or not. Okay, so I can use that. So that is the job of that screw. Anyways, that's not the point. Okay, now let's go to the next concept, MSD and VSD. What is this MSD and VSD? MSD, it is not MS Dhoni. Somebody said MS Dhoni. And what is this? Virat Singh Dhoni in a parallel universe. Mahendra Singh Dhoni, Virat Singh Dhoni. No, no, no. MSD means main scale division. Main scale division. And VSD means vernier scale division. That short form we'll be using throughout our lecture. Mean scale division, vernier scale division. All right. Great. Till this point. Yes, Vijaya, I definitely do remember you. Sir, what that up and down will measure? Up and down means which up and down? This up, like I said, this one measures inner widths. This down one measures outer diameters, outer thickness, etc. Is that clear? Okay, fair enough. Now, what is the meaning of main scale division? See, guys, can you see this is that main scale? Each division has a length. Each division has some distance between first to second to third to fourth. That is called main scale division. So it is the distance between the consecutive divisions made on the main scale. Usually, 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 it is a millimeter. It is not necessary. It is usual, but we might get any kind of question. Okay, it could be anything, guys. Like it could be 2 millimeters, it could be 0.5 millimeters, it could be any special vernier caliper as well. Vernier scale division usually is nothing but usually 0.9 millimeters. Usually it is 0.9 millimeters. Let's have a look at it. If I put over here, can you see that 0, 1, 2, 3, 4, 5, this is 5 millimeters or 0.5 centimeters. This is 1 centimeter. Can you see this is nothing but 9 millimeter or 0.9 centimeters? How many of you are able to see that? If not, I will use another image over here. I'm pretty sure through this also you can see it, or even this one. Maybe I can zoom onto it a little bit. Okay, fair enough. Yeah, this is a good zooming that I have done. As you can see, this is the 9th division of the main scale. I hope you are able to see that. This particular thing over here is nothing but the 9th division of the main scale. This is technically speaking, 9 millimeters. This is technically speaking, this one over here is 9 millimeters. This is technically speaking 10 millimeters, which is also 1 centimeter. That's why that number 1 was there. The 0.5, everything is in centimeters. If you convert it into millimeters, this is 10 millimeters. So this is 9 millimeters from here to here. In that 9 millimeters, can you see 0, 1, 2, 3, 4, like that 10 divisions of vernier scale are there? There are 10 divisions of vernier scale there are 10 divisions of Vernier scale for basically 9 millimeters of our main scale. 9 millimeters of main scale have 10 divisions, 10 divisions of Vernier scale. So if you ask me what is 1 VSD, 1 Vernier scale division, you will take 9 millimeters, and since there are 10 parts, you divide that 9 millimeters divided with 10 parts, you will get 0.9 millimeter. You will get 0.9 millimeter. So you can see each part is slightly less than a millimeter. It is 0.9 millimeters. So that's why you can see it is slightly smaller than a division on the main scale, which is typically a millimeter. So this much is nothing but 1 MSD, which is a millimeter, 1 millimeter. But if you see this much, that is basically 0.9 millimeter, which is Vernier scale division. Is this absolutely clear? Is this graphic clear? Everybody with me? Okay. Yes, with this lecture, we'll be completing the first chapter. Definitely. Great. Okay. Awesome. 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 Till this point, absolutely clear. Okay, sir. Done, sir. Sir, what if the number of divisions are different? Okay, let's take some different divisions. Let's take maybe, oops, I can't do that here. Let's take this like this. Okay, okay, over here. Just see, in this scenario, how many divisions are there on the main scale and how many divisions are there on the Vernier scale. If you notice, this is basically your 4 millimeters. This one is basically 4 millimeters. In the Vernier side, 0, 1, 2, 3, 4, 5. This is the fifth division. So 5 divisions of Vernier scale are nothing but 4 millimeters on the main scale. So if I ask you VSD, one Vernier scale division, one Vernier scale division. So take 4 millimeters, divided by 5 parts. Divide it by 5 parts. Can you see that? So that is going to be 0.8 of a millimeter. 0.8 of a millimeter. Everybody with me on this? Understood? Give me a thumbs up. Excellent, precious. Perfecto, Shravya. Very good. Awesome. Amazing. Let's take one more example. Let's take one more example. Maybe instead of 15, we take, let's say, for example, Chumma, I've taken 20. Some new Vernier caliper. Okay, some new Vernier caliper. Come on, let's do it, my dear students. Okay. So over here, as you can see, this is 1 centimeter, this is 2 centimeter, this will be 2 centimeters means 20 millimeters. So technically this is 19 millimeters. This is 19 millimeters. 19 millimeters has 20 divisions of Vernier scale. So 20 divisions of Vernier scale equals 19 millimeters of main scale. So that means 1 VSD. 1 VSD is this much. So that would be equal to, take that 19 millimeters divided by 20 parts. So 19 millimeters by 20. 19 by 20 millimeters. Is this clear? That's how you find 1 VSD count. Now, why is that VSD and MSD important? Why do I need MS Dhoni? Why do I need Virat Singh Dhoni? Okay, let us understand that. We need that in order to find the least count. And before going ahead, so usually what is mentioned, so usually the number of divisions of Vernier scale that coincide with main scale is given. So from that we can easily find VSD. So the Vernier scale division will be basically the the main scale division, main scale value, maybe it is in millimeters, divided by the number of vernier scale, a number of divisions on the vernier scale, we can say. So number of number of divisions on the vernier scale, on the vernier scale. You don't have to remember this. Please don't remember this formula. It is very obvious. It's simple. I just made you calculate over here. Okay, we just did the calculations over here. So it is very simple. Now we need that for calculating the least count. That is the smallest value that can be counted using this scale. So the least count, the least count of a vernier caliper. This is very, very important formula. There is a big modulus and it is MSD minus VSD. MSD minus VSD mod value. Reason why there is a mod, because sometimes VSD can be more than MSD. So you might get a negative value. So we should always get positive value for least count. That is the only reason why we have put a modulus over here. So the least count of a vernier caliper is MSD minus VSD. Let me show you an example. Let's take this only. In this scenario, in this particular scenario, as one can see, that 9 millimeters coincides with 10 divisions of vernier scale. So vernier scale division is 9 by 10th of a millimeter. 9 by 10th of a millimeter. 9 millimeters you divide into 10 parts, that is 1 VSD. So what will be the least count? So what will be the least count? The least count by logic is MSD minus VSD. What is main scale division? Each division on the main scale is 1 millimeter. You subtract from it this particular value, which is basically 9 by 10th of a millimeter, and put everything in modulus. So that will be 1 minus 9 by 10 is 1 by 10th of a millimeter. 1 by 10th of a millimeter. 1 by 10 mod is 1 by 10 only. So that is 0.1 millimeter. So the least count of this vernier caliper is 0.1 millimeter from this formula. This is how you can calculate it. Straightforward. Okay, let's take another example. I will show you another example, my dear warriors. Let's take maybe, okay, some more count. Let's take maybe some more count. Okay, let's take 20, the one which we just did before. What will be the, what is this? Okay, let's do this. So in this particular scenario, we just saw this was 19 millimeters. 19 millimeters was 20 divisions of vernier scale. So one vernier scale division, take that 19 millimeters divided by 20. Okay, now let's find out the least count. Least count will be modulus MSD minus VSD. MSD minus VSD. What is one main scale division? Check this out. How much is this much? This is 1 millimeter, 1, like that. It is 19 millimeters. So one division is 1 millimeter minus VSD is nothing but 19 by 20 of a millimeter. Okay. So 1 minus 19 by 20, it is nothing but 1 by 20 of a millimeter. Mod value not needed. What is 1 by 20? That is nothing but 0.05 millimeter. Wow, this is such a good vernier caliper. Least count is 0.05 millimeter. Everybody got it? Excellent, precious. You guys got it fast. Yes. Okay. Please consider, while error analysis, it is compulsory to consider significant every time. Yes, Ajay, you have to consider it every single time. Okay, no doubt about it. In fact, the question only you will see when you read the question only, you will understand some decimal places options are there, much variations are there. From that only you will understand the question is only on significant figures. Okay, all right. So just to be very, very clear, VSD over here is nothing but This, sorry, VSD over here is nothing but this. This is VSD. This is Vernier scale division. From one division to next division on this scale, that is Vernier scale's division length. Vernier scale division length. Okay, that is one VSD basically. And if you ask me main scale division, that is this one. This is main scale division. Every marking will be a millimeter. 0, 1, 2, 3, 4, 5 millimeters. This is basically 5 millimeters. This is basically 10 millimeters. See, this one which is written down over here, that is basically centimeters. Don't get confused. This 2 which is written down, it is centimeters. Okay, that is the confusing part. So always convert centimeters to millimeters to be very, very clear about it. Millimeters is easy to work with. Is that now clear? So this is 1 millimeter each on the main scale. This is one VSD on the Vernier scale, but one VSD is different. It is slightly of different value. You can see that's why it is going slightly off. So you take this 19 millimeters actual length, divide it in 20 parts. So if you divide in 20 parts, you get VSD. And if you subtract both of them, you get least count. Is that absolutely clear, Abhijit? Right? Okay. But now the question really arises, why is it that their difference gives me, a least count? For explaining that, let me just take some lesser value over here. Let's take 10. Can you see right now? This first division, they are slightly off by some amount. This division on the main scale is 1 millimeter. This is 1 millimeter. This is 0.9 millimeter. How much should I move the Vernier scale so that these divisions coincide? Answer in the chat box right away, right now. Answer in the chat box. How much should I move this so that this main scale and Vernier scale divisions coincide? Remember, this is 1 millimeter. The bottom one is 0.9 millimeter. Yeah, we just did that calculation. Obviously, if this is 1, this is 0.9, the difference is 0.1. So if I move this exactly by 0.1, then you can see they will coincide. Yeah, exactly by 0.1. Okay, very good. Now look at this line over here, this second line and this line over here. How much should I move the Vernier scale by so that this second division coincides with some division on the main scale? This second line on the Vernier caliper should coincide somewhere. First time, how much should I move it? Well, think about this. Is this 1 millimeter? This is 1 millimeter. Total is 2 millimeters. This is 0.9. This is 0.9. This is 1.8 millimeters. So this much length is 1.8. This much is 2. So the difference will be 0.2. So if I move this by 0.2 millimeters, it will perfectly coincide. Oh, now I'm getting a hang of it. So you are telling me if I want to make the fourth division coincide, I will have to move it by 0.4 millimeters? 100%. 100%. I have to move it by 0.4 millimeters because this much length will be, if you want, I'll just mention it over here. Just check this out. This much length from here till here will be 4 millimeters, but this much length from here to here, just think about it, 0.9, 0.9, 0.9, 4 times, that will be 3.6 millimeters. So that gap which is there, between this and this, the gap which is there between this and this much is 0.4 millimeters, which is 4 times the least count. 4 times our least count. Our least count was 0.1 millimeters. So I have to move the Vernier scale, by 4 times the least count so that they will coincide. Now it makes sense why the least count is 0.1. It's the difference of the main scale and the Vernier scale. Whatever is that small difference, that itself becomes the least count. That is the smallest movement that you can make so that these lines will coincide with one of those lines on the main scale. Whichever line it coincides doesn't matter, but to coincide, you need to move it in multiples of the least count. Some multiples of the least count. Only then they coincide and I can make our measurements based on this coincidence. Is that absolutely clear, my dear warriors? All right. I was born in Tamil Nadu in Salem. Yeah. Yes. Right. Okay. Perfect, sir. I understood, sir. Now this one. Cool. So that is how we measure the least count. Shall I remember this formula? Yes. This is something which I'm blocking it for you because you need to remember it. Okay, sir. Can we do some questions on this? Why not? Here it comes. On the 1 centimeter main scale of a vernier caliper is divided into 10 parts. 10 divisions of the vernier coincide with 8 divisions of the main scale. Then the least count of the vernier caliper is. First, write down basic things. What are the basic things? Look at it. 10 divisions of vernier caliper coincide with 8 divisions of the main scale. First, tell me 8 divisions of the main scale means how much? Think about it. One main scale division, because the centimeter is divided into 10 parts. 1 centimeter you divide it by 10 parts, that is 0.1 centimeter, which is basically 1 millimeter, which is a normal usual case. So this MSD I can directly get from this information. Is divided into 10 parts. A main scale, which is 1 centimeter divided into 10 parts. So each part is 1 millimeter. 10 such millimeters makes a centimeter. Okay. Now listen to this carefully. 8 divisions of the main scale means? 8 divisions of the main scale means it is basically 8 millimeters of our main scale. 8 divisions of the main scale is 10 divisions of vernier scale. 10 divisions of our vernier scale. So, one division of our vernier scale division will be, you take that 8 millimeters and divide it by 10, which means it will be 0.8 millimeters. So, a VSD is 0.8 millimeters from here because 10 vernier divisions made 8 millimeters. So a division will be 8 millimeters divided 10 times. Now we'll apply our least count formula, which is Mahendra Singh Dhoni minus Virat Singh Dhoni. Okay, fine. So MSD is 1 millimeter. VSD is 0.8 millimeters. Luckily, this is bigger than this, so it is going to be positive. Hence, it will be 0.2 millimeters. Not that great, but still better. So, 0.2 millimeters is the same as 0.02 centimeters. So, 0.02 centimeters is option B. Is this absolutely clear how we did this question? Are you getting a hang of it? And so glad, Pratik. And keep watching, keep learning, keep improving. And soon I would be seeing your comment, maybe a story, just like I received so many stories and messages from all our students passing out this year. Sir, I'm in this IIT, I'm in this NIT, I'm in this college. I got CSE, I got AI. Very soon, maybe 2 years, 3 years, I don't know, whichever standard you are in. Accordingly, we'll be seeing you in a great college very soon. Okay, keep watching, guys. All right. Next question on your screen, where there are no numeric values, completely in variables. In a vernier caliper, a main scale division is x centimeter and n divisions of the vernier scale coincide with n minus 1 divisions of the main scale. The least count is how much? Okay. So in a vernier caliper, 1 MSD is x centimeter. So already MSD is given. One main scale division is x centimeter. MSD is basically x centimeters. Okay, MSD is done. Now let's talk about VSD. The n divisions of vernier scale, they are coinciding with n minus 1 divisions of the main scale. N minus 1 divisions of the main scale means n minus 1 multiplied by x centimeters on the main scale. On the main scale. Think about it in terms of length. Each division on the main is x centimeters. Like that, you take n minus 1 divisions. So n minus 1 x centimeters on the main scale is the same as n divisions of the vernier scale. So a VSD will be, you take n minus 1 times of x whole thing divided by n, that many centimeters. So that is a VSD. Now least count. Least count is MSD minus VSD. MSD is nothing but x. VSD is this thing n minus 1, the whole thing by n multiplied by x, this all in centimeters. No need of mod because this is a smaller value. I can take x common and this will be 1 minus n minus 1 by n, all right, in centimeters, which is nothing but x common. You have n minus n plus 1. Why plus? Because minus minus will be positive, the whole thing by n in centimeters. So this will be n cancels, this will be x divided by n centimeters. That is your least count. X by n, that is option number C for Captain Shreyas, your physics master teacher. Yes, Captain Shreyas. Correct. Pratik, you're in class 11th? Well, JEE 2027 it is. So I'll be waiting for 2 years. Right? Cool. Yes, very good, Shravya. Yes, option C. I hope this is absolutely clear. Abhijit, it's option C. Yeah, B, I guess, was your previous answer. Yeah. Yes, B was the previous answer. Perfect, sir. I understood this. Now, let's see how do we measure using the vernier caliper. How do we get the reading of it? Now, in order to get the reading, the reading of a vernier, the answer is add something called as the main scale reading. MSR is basically your main scale reading, add it to the least count multiplied by the vernier scale reading. LC is obviously least count. I will not bother explaining it again. Vernier scale reading. This is vernier scale reading. And eventually minus something called as zero error. Now, vernier scale reading is the division of our vernier scale that coincides with some division, doesn't matter which one, some division of the main scale. Never measure the main scale. VSR means vernier scale reading. So check which vernier division coincides with any division of the main scale. This becomes the formula for the reading of the vernier caliper. We'll come to zero error also in a bit. Now, before going to zero error, let's understand what does this formula exactly mean. Let's go back to this. What is the meaning of main scale reading? Let's say for example, I put something over here and I clamp the claws like this and I leave it over here. Now I want to see what is the main scale reading. Check the zero of the vernier scale. The zero would have crossed some line on the main scale. Which line has it crossed? 0 millimeter, 1 millimeter, 2 millimeter. It is between 2 and 3. So the answer will be 2 point something millimeters. That is 100%. The answer will be 2 point something millimeters. So in this particular question, can you see, my dear students, the main scale reading? The main scale reading is basically this particular number 2. It is 2 millimeters. 2 millimeters. Leave it. Okay. Next, this least count, we already calculated it. It was basically 0.1 millimeter. I will leave it like that only. What about the vernier scale reading? See, check the vernier scale. Some division somewhere is coinciding with something on the main scale. Can you count and tell me? Can you count and tell me? All right. Yes, Muthunri, all right. Partial droppers, you need a plan. Noted. Can you count and tell me 0 to 4? I think this one. Can you see this is coinciding over here? 0 to 4. This is the fifth division. So the main, sorry, not the main, the Vernier scale reading VSR is basically 5. VSR is basically 5 because that is the division which is coinciding. Yes, very good. Not 11. No, definitely not 11. 11, where is 11? I can't see 11. Guys, this is not even a line. Only till 10 the divisions are there. So if you ask me what is the reading, what is the reading? The answer will be take the main scale reading. How much is it? 2 millimeters plus least count. How much it is? 0.1 millimeters. Multiply the least count with VSR, which is basically 5. So this will be nothing but 2 plus 0.5, which is 2.5 millimeter. That is the answer. Simple. That's how easy it is to measure using a Vernier scale. Is this absolutely clear? Shall we do one more question, my dear warriors? Yeah. So main scale reading means check the zero of the vernier. Who is it crossing on the main scale? The zero of the vernier is crossing the number 2. So 2 becomes main scale reading. Check vernier scale, which division is coinciding somewhere. This division is coinciding. So main scale over here, vernier scale over here. Main scale on the main scale, vernier scale reading on the vernier scale. That is how it works. Always multiply vernier scale reading with least count. Okay, let's again take randomly, guys. I'm just randomly moving it, and let's say it has stopped over here somewhere. Okay, just to I'm moving it, meaning I put some object over here, and I want to see what is the length now. Okay, what is the length now? So let's go back over here. Now, guys, quickly think and tell me. Quickly think and tell me what is the main scale reading in this scenario. Quickly look at it. The zero has crossed 1. The zero has crossed 1. So the main scale reading is basically 1 centimeter, which is 10 millimeters. Okay. Least count is still 0.1 millimeter. Okay. What about vernier scale reading? I can see the fourth division is coinciding here. So vernier scale reading is basically 4. So the final reading will be main scale reading, which is 10 millimeters plus least count, which is 0.1 millimeter, multiplied by the number 4. So this will be 10 plus 0.4. So hence it will be 10.4 millimeters, which is 1.04 centimeters. Is this absolutely clear? So the answer is 1.04 centimeter or 10.4 millimeters. Clear, guys? Everyone? How many of you wrote it? Very good. Awesome. 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 Perfect. Any other value? Let's take it. Yeah. Any other value? Let's just move it around. Okay. Something, let's say like this. Okay. Let's take this. Okay. Just some random thing I've chosen. Oh, I can zoom it like this. Okay. Oops. What is this? Okay. Check this out quickly and tell me what is the vernier scale reading, main scale reading, everything. What is main scale reading, guys? The zero has crossed this guy. What is this? 15, 16, 17. It is 17 millimeter. What is the vernier scale reading? Okay, vernier scale here. 0 to, this is coinciding. I think it is 3. So our reading will be 17 millimeters plus least count, which was 0.1 millimeter, multiplied by this number 3. So this will be 17 plus 0.3, which is 17.3 millimeter, which is 1.73 centimeter. 1.73 centimeter. Done. Dusted. Awesome. Yeah. Got it? So now they can give you diagrams and or they can mention it in words also. Don't expect every time you will get this diagram. Okay. Sometimes JEE advanced questions will come with a diagram. Sometimes they will give you in writing. The zero of the vernier scale has just or is in between 17 and 18. That's how they will mention in words. The zero of the vernier is between 17 and 18th division of the main scale. Then third division of the vernier coincides with some division on the main scale. Oh, vernier scale reading is 3. That's it. Instead of diagram, they can give in words. Still, you will be able to do the question. Okay. Now that we have understood this concept, let's also go to something called as the zero error concept. Zero error concept. There are two kinds of errors. Zero error can be positive or negative. Okay. Zero error can be positive or negative, or there can be no error at all. What is the meaning of zero error and why should I subtract? The types of zero error are basically, I've just mentioned it over here. Zero can be positive or negative. And why do I need to subtract that zero error? Let's understand that. Okay. So let me take you back over here. Let's zoom this out. Can I? You come back. Okay. This has come back over here. Let me bring it back like this. Now, notice how when there is nothing in between, the zero of the vernier coincides with zero of the main scale. It should how ideally it should be. I mean, when there is nothing in between, the clamps will touch each other. I'm measuring nothing, so it should be showing me 0 millimeters. But there is an error in that, meaning, imagine something like this. Oh, my clamps are touching, but wait a minute. I'm already seeing some reading. I'm already seeing some reading. Okay, William, I'm doing it here. So watch it. And maybe I would have not done in Roar. Don't worry, because I would have done it in Nurture or Pathfinder. Okay. So somewhere or the other, I will find it. I would have done it. So it is not necessary that, sir, in this series, you should do all these things. If I tell, watch this lecture here, you should watch it. Okay. Don't be like a school going boy. Sir, ma'am, you didn't do this thing in this part. So I want it in this series. What is this? I have to maintain one system or what? Okay. If I have done it somewhere, I will show it to you. Don't worry. All right. So there is some error over here. There is some error over here because already I'm getting some value. So even without anything, I am getting how much exactly? Just check it out. Even without anything in between, I'm already getting something. How much am I getting? The zero over here has crossed zero. So the main scale reading is basically zero. Least count being 0.1 millimeter. Vernier scale reading, vernier scale, I think the fifth division is coinciding. So that is 5. So I will get a error zero error, which is now positive. Why is it positive? Because I am crossing the zero. My zero of the vernier has crossed zero of the main scale. I'm already ahead. I'm getting some value already. So it is a positive error. And use our normal technique. Main scale reading is 0 plus least count is 0.1 multiplied by vernier scale reading. So that will be basically 0.5 millimeter. So my zero error is positive in nature. My zero error is positive in nature. What does this mean? Let's say I move this and next time when I actually place the object, the object reading, let's say the object reading comes out as 2.7 millimeters. Remember, in that 2.7, 0.5 was already there even without anything. So the actual object length, actual object length will be 2.7 minus 0.5 millimeter. So it should be 2.2 millimeters. Do you understand why I have taken that out? Why I have taken that out? Because that was already there. That zero error was already there. It was already showing me 0.5 millimeters. This much is 0.5 millimeters, which should not be there. So I'm taking it away to get the actual measurement. Yeah. Now, this is kind of positive error. What is the meaning of no zero error? If there is no zero error means it will be like this. The zero will coincide with zero. Zero error is zero. Zero error is zero. Okay. This is zero error is positive. What is zero error is negative, sir? It will be like this. So I take this and I move it over here. Oh, this is negative error. So maybe in this scenario, I have a negative error. Chumma, I'm just putting it down over here. Maybe the negative error is minus 0.7 millimeters. Chumma I have put. This is my zero error. So let's say the object reading, comes out as 2.3 or let's say 2.1 millimeter. So the actual object length, how much will it be, guys? Then it will be 2.1 minus 0.7. So that will be 2.1 plus 0.7, which is 2.8 of a millimeter. 2.8 of a millimeter. Yes. So when it is negative means you are getting some negative value when there is nothing in between them. If you are still confused, I will ask you to imagine a weighing machine. Just imagine a weighing machine. Yeah, everybody would have seen a weighing machine and digital readings are shown. Imagine nothing is there on it and it shows minus 2 grams. Now, if you stand on it and it shows 70 grams, obviously my true weight is not 70, it is 70 plus 2, which is 72 grams because it was showing negative 2 value. But let's say it was showing positive 2, then I will take away minus 2 from it so that my answer will be 68 grams. Is that right? If it was showing positive 2, I'll take it away. If it was showing negative, I will make sure I compensate for it accordingly. So you might have seen sometimes shopkeepers do that because the box that is there, that itself has some mass. So you would have seen this as a common practice. Imagine the tray itself weighs 5 grams. So you will see that the weighing machine, which is there, if there is nothing on it, it will be showing minus 5 grams. Don't get scared because it is showing minus 5. Because if you put the trolley on it, then that minus 5 plus 5 will make it 0. So if you have filled some tomatoes, in it, maybe worth 70 grams. So when you place that particular box over here, with tomatoes, that zero error has been compensated and you will get 70 grams. Understood? You would have seen this at some shopkeeper or some supermart, etc. Is this clear, everyone? What is this concept of zero error? Put some fire emoji quickly in the chat box, just like Vasuke did. Hello, Captain, attendance mark. Thank you so much. Yes, observed it in the shops. Very good. Next time, if you have not observed it, please observe it. Okay. If there is no negative, that means the shopkeeper is fooling you, because the mass of the trolley will also be something. So that is already then getting added to the tomatoes mass. So if it is showing 0, so the trolley's mass plus the tomatoes mass, so you are getting less tomatoes. Keep that in mind. Yeah, very good. So this is the concept of zero error. So that's why zero error will always be subtracted. If it is positive, so minus that positive value. If it is negative, negative plus negative will make it positive. Yeah, automatically. Yeah. So the types of zero error will be like the positive ones. The positive zero error will be where the zero of the Vernier scale is to the right of the zero of the main scale. Is to the right of the zero of the main scale. The negative error is where the zero of the Vernier scale is to the left side of the zero of the main scale. Yeah, this is negative error. And when there is no error at all, there is zero error at all. So then the zeros are perfectly matching. The zero of the Vernier scale matches with the 0 of the main scale. So this is no error at all. Zero error, or zero error itself is 0. Okay, so these are the types of 0 error. Okay, sir, understood. So let us do some questions on this. Here comes the question coming up on your screen. In a Vernier caliper, we have done the basic questions. Let's do some JEE question also. In a Vernier caliper, when both the jaws touch each other, the 0 of the Vernier scale shifts to the left and its fourth division coincides exactly with a certain 0 of the Vernier scale shifts towards the left and its fourth division coincides exactly with a certain division on the main scale. The 50 Vernier scale divisions equal to 49 main scale divisions and the 0 error in the instrument is 0.04, then how many main scale divisions are there in a centimeter? Let's do this. Yeah. Right. So let's have a look at it. Let's have a look at it. 50 Vernier scale divisions equal to 49 main scale divisions and the 0 error in the instrument is 0.04 millimeters, then how many main scale divisions are there in a centimeter? Guys, this is not a regular scale. That is why it is a JEE question. A lot of people will think, sir, in a centimeter there will be obviously 10 divisions, but that will not be the answer most likely. Yes, it is not the answer. You can say the answer is something else. Okay, don't worry what the answer is, but just showing you, lot of people will think in a main scale 1 centimeter means 10 millimeters, so 1 millimeter is one division. That is wrong. Okay, cool. So let's assume one main scale division is x, whose value I do not know. That is what we need to find. Okay, zero error is also mentioned. 50 Vernier scale divisions equal to 49 this thing, and the what is that, least count is not mentioned over here. The scale shifts and its fourth division is coinciding, that much is also mentioned. So now what do I do? Just think about it. See guys, over here, as you can see, 0.04 millimeters, 0.04 millimeters is the zero error, which is basically the total reading. You can think of it like that. This will be, because I have moved it 4 times, because I have moved it 4 number of. Hello, I hope I'm audible and visible. I'm so sorry we got disconnected. So sorry. Yeah, and guys, I was just checking, you guys are not liking. Come on, quickly smash that like button in case you have forgotten. So let's come back again. All right. So the zero error is 0.04 millimeters is the zero error. And it happens when you move the Vernier scale by 4 times. The fourth division is coinciding. So this zero error will obviously be the number 4 multiplied by the least count. Multiplied by the least count, because 4 divisions are being moved for it to coincide. Then the distance that you are covering is 0.04, or sorry, 0.04 millimeters. So that means this distance is least count multiplied by 4. So how much is basically the least count? The least count will be 0.04 by 4, which is 0.01 millimeter. Just keep this aside now. Just keep this aside. Yeah, I hope I'm audible and visible, guys, to all of you now. Now we know the least count formula. What is the least count formula? Least count is MSD minus VSD. MSD minus basically VSD. Okay, MSD minus VSD. Least count is 0.01. Main scale division. Oh, that is exactly what I do not know. That is exactly what I do not know. I'll put it as X. Minus VSD. How much is a Vernier scale division? 50 Vernier scales coincides with 49 main scales. So that means 50 divisions on Vernier scale is equal to 49 multiplied by X on the main scale. So that means the VSD will be 49 by 50 times of x. So the Vernier scale division is 49 by 50 multiplied by x. So this is going to make it x multiplied by 1 minus 49 by 50 is 1 by 50. That is 0.01. Therefore, x will be equal to, how much? 50 multiplied by 0.01. That is nothing but you take one decimal in, so that will take out this 0, and one more decimal, so that will be 0.5 millimeters. So each division on the main scale is 0.5 millimeters. Now going back to the question over here, how many main scale divisions are there in a centimeter? So guys, if x is 0.5 millimeters, which is one main scale division, so if you take a centimeter, if you take 1 centimeter, which is basically 10 millimeters, how many divisions will be there? You take that 10 millimeters and divide it by 0.5 millimeters. How much are you going to get? You are going to obviously get 20. So 20 divisions are there. 20 divisions are there. So the answer will be D, which is option 20. Yeah. Yep. Is that absolutely clear? Awesome. Hello, Mayuri. Yep. The weightage of this chapter, usually bare minimum 1, sometimes up to 3 questions, indirect or direct. Indirect means as a combination with some other chapter. But very rare it is. But typically 2 questions out of 25 questions. Okay. 1 is bare minimum, but typically it can be up to 3 questions or 2 questions. Usually you will find it in on an average basis. Okay, sir. Understood. Now shall we go to micrometer, guys? Vernier is absolutely clear. We did questions on zero, error, and least count, calculating everything. This is done. Yeah. So if you are wanting the explanation of this particular question once again, here is the thing. See, there was a zero error of how much? 0.04 millimeters. So think of it like this, that I had to move behind by 4 times the least count so that the fourth division would coincide. Here it is not exactly coinciding, but yeah, so that the fourth division will coincide. All right. Now, if I move one division, I have moved one least count. If I move 2 divisions, 2 least counts. If I move 4 divisions, 4 times of the least count. So that much is basically the least count. That much is basically the zero, which is mentioned over here. From this, I calculated least count. Second thing, I calculated VSD by this data point. 50 Vernier scale divisions were exactly 49 main scale divisions. Each main scale was x centimeter. So from this, one VSD was 49x by 50. Use this in our least count formula. So I got the value of x. What is x? X is basically from one main scale to next main scale division. It is one MSD's length. That was 0.5 millimeters. So if it is 0.5 millimeters, how many such divisions should be there in a centimeter? Well, take that centimeter, which is 10 millimeters, divided by 0.5. You will get how many divisions are there in a centimeter. Because that is what the question was. 10 centimeters is nothing but 1 centimeter. So you divide this, you will get 20 divisions. Is that clear now? Perfecto. Okay. Yes, Sumit, I have explained it whole thing once more time, just in case you are confused, because this was a very unconventional question. That's why we are doing PYQs also, so that you understand the whole concept. And in J, see, if you just remember this particular formula, this is of no use. I mean, not no use, I'm not much use every time. Sir, I by-hearted this formula. What is the use? No use. But after today's class, you know what exactly a main scale, Vernier scale division is, what least count is, how it is measured. Then if you apply that concept, you will not go wrong. Is that okay? Now, there is one common mistake which happens in the negative error though. A lot of people have made mistakes, and this is a JEE advanced question. Guys, let me show you this particular question itself. Okay. Can you guys quickly tell me what is the zero error in this? Can you guys quickly tell me what is the zero error in this particular diagram? Come on, let's see how many of you are able to tell me this. Yeah, how many of you are able to tell me this? This is between 0 and let's say this will be 1, 2, 3, like that. Divisions will be there, 4, and then again over here, like that. So divisions are there behind, but these are negative divisions. Can you quickly tell me what is the zero error in this problem? A lot of you might make mistakes, but be very, very careful. Yeah, come on. Some of you are saying 0.6. Guys, first of all, tell me what is the main scale reading? Is the main scale reading 0? No, 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 no. It is -1. Be careful. It is -1 millimeter because the 0 has just crossed -1. Can you see that? This particular value is nothing but -1 millimeter. So the 0 of the vernier has crossed the -1 mark. So it is -1 millimeter. If you see the division, the vernier scale reading is basically 6. Vernier scale reading is basically 6. So the zero error, the zero error will be main scale reading is -1 millimeter plus least count, which is 0.1 millimeter multiplied by 6. So that will be -1 millimeter plus 0.6 millimeters. So it will be minus 0.4 millimeters. So this is negative error. So the negative error is 0.4. Getting it? So a lot of students make this mistake in the main scale reading. They think the main scale reading, I have to go left side like this. No, no, don't take mirror image. Just see which reading has it crossed just now. Got it? Yeah, it is not 0, it is -1. That is the common mistake. Hello, Srinav. How many of you understood? Isn't this a very nice, tricky question? Okay, if I can't change this now. How much? Okay, I can just go till here. Even now the zero error is still here. But if I could draw more divisions, always check that previous division on the left side. Don't go from right to left. Always go from left to right. Okay, a very nice concept. All right. So going to the micrometer screw gauge part. Yeah, this is how a micrometer screw gauge looks like. This is actually much more simpler than the vernier caliper. Vernier caliper still, that divisions and all of that. This is much simpler. So you can see you have a frame over here. This is the sleeve. This rotating part, the thimble. There is a ratchet over here. There is a spindle and there is an anvil. These are the parts. Even if you don't know the parts, it's okay. This is not a board examination. Fine, labeling is one thing. But this is a framework. This is the sleeve, just like you put on a shirt on a sleeve, right? You say, these are my sleeves. Yeah, this is a shoulder you put on a sleeve. That's like a sleeve. So it's like you're putting a cloth on it. This is the thimble. This is a ratchet. And there is a spindle. That spindle means the thing which moves back and forth. And you put the object being measured over here. Okay, fair enough. So that is a micrometer screw gauge. Now, let's see what is the least count of it. So let's see what is the least count of it. Before going to the least count, there is something called as the pitch. The pitch of micrometer screw gauge. And the next thing is the least count. Next thing is the least count of a micrometer screw gauge. So these are the two important formulas. What the hell is this pitch? Okay, let's go. I don't need vernier anymore. I need micrometer. Oh, let's zoom out a little bit and get this micrometer. As you can see, this is a frame, the sleeve, this is the thimble, this is the ratchet and all of that. As I rotate this, this is the rotatable part, that thimble. As I rotate it, it goes back and forth. Screw. What does a screw do? Everybody has seen some kind of screw. For example, this particular screw over here, the screw over here. What does the screw do? As you rotate it, it goes inside. If you rotate it other way, it comes outside. You rotate it this way, it goes inside. You rotate it other way, it comes outside. That is what a screw typically does, isn't it? You can see some threadings are there. Some screws, you have to rotate it many times, zoop, 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 then it goes little. But some screws, you rotate it few times, zoop, it has gone inside. So that is basically the concept of pitch. Pitch is, if you rotate it once, how much in or out it goes. That is the pitch. So if the pitch is more, means if you rotate it few times, it travels more linear distance. The threadings are more slanting. It goes in and out a lot. Clear? But if the pitch is less, rotate, 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 rotate. Now it is going. And you would have seen it during opening or closing time of shops. How many of you seen the shutter going up and down? And one Chotu, one worker, one Pandu will come and he will be like, zug, 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 he is doing. He is using one lever and he is rotating the shutter. Slowly it is opening. You are waiting. When will Anna give me sweets? Sweet shop. You are standing outside and Anna is still rotating it. The shutter is slowly opening. You're losing your mind, you're losing your patience out of it. The pitch is very less. Yeah. How many of you have done that? Yeah. So, Vijaya Lakshmi, more pitch means, is it easy? No, no, no. More pitch means it is very difficult. Just think about it. Within few turns, it has to travel more. So you have to use lot of power in one rotation, and it has to pierce in it, or it has to travel a large distance. So you need more effort. But when the pitch is less, you keep rotating very easily. Okay. You can keep watching some reels and scrolling, and you are just doing it very less power, very less effort. But still, you are doing it. Yes, the time taken is more, but that's fine. You are putting in less effort. Yeah. Pitch is not related to the tightness exactly. It is related to the threading. How much is the threading between in a screw? Like, how angled they are. You might have seen these threads. I don't know whether you can see it. These threads. So if they are very closely spaced, many threads are there, the pitch is less. But if the spacing between the threadings is more, that means you rotate it few times, zoop, it will move a lot. Okay. So that is the meaning of pitch, guys. So here, as you can see, this 0 is there. Let me just zoom onto it. I will slowly rotate it. Can I? Yeah. 10, 20, 30, like this, like this, like this, I rotate. Oh, I came to 0. Can you see? I came back to 0. So once I rotate complete circle, how much do I move? That is the pitch. So guys, can you quickly calculate and tell me how much is the pitch? Because see, I came back to 0 once and I moved something. Well, you'll be like, sir, I can't see the reading, sir. Okay, I will move it one more time. Maybe you will be able to see it. See, I have moved 2 times. Then I will move it one more time. And this is 3 times. So every time I move, I'm going one division. Every time I move, rotate it once. Check this out, 0. Slowly rotate, 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 rotate. So back to 0, one division. Again, rotate, 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 and back to 0. One more division. Again, rotate, 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 rotate. One more division. So for one round, I am moving 1 millimeter. So can you guys tell me what is the pitch? No, 45 is not the pitch. Guys, 45 are the number of division. 45 is the marking on the circular scale. This is circular scale. This is the main scale. This main scale, one division is 1 millimeter. Agree or disagree? One division, 1 millimeter. This is circular scale. If you ask me how many divisions are there on the circular scale, I have seen many people tell 45. No, it is not 45. Think again. 45, 46, 47, 48, 49, 50. So 50 is like reset, 0. So 50 divisions are there, but I can't put 50 because 50 is back to 0. So you start the count from, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you come to 49 and then 50. 50 is actually 0. You're resetting it. Getting it? Okay. Everyone till this point, absolutely clear? Awesome. Awesome. So the pitch over here is basically a millimeter. Let us do one thing. Let us change it something else. Okay. Now think, if I rotate it. Okay, 70, 80, 95. Don't say number of divisions on the circular scale are 95, because you can see probably 95 units over here. No, 96, 97, 98, 99, 100. So if I reach to back to 100, I'm reaching one division on the main scale. That is what it is. Okay. Perfect. Perfect. Now, let us say, okay, I can't do much over here, but still, right? Okay, so let me go back to pitch. So pitch of a micrometer screw gauge is nothing but the distance moved on main scale, on the main scale, on one rotation, on one rotation of circular scale. Circular scale. So on one rotation of the circular scale, the main scale, how much are you moving? Okay, the main scale, this is the rotating or the circular scale. This much is clear? Perfect. Now comes the simplest formula, least count of a micrometer screw gauge. See guys, the least count is very simple. Over here, yeah, there were 50 divisions. If I just move this thimble by just 1 unit, just look at it, 1 unit. I don't know, I can barely move it. Okay, I just moved it 1 unit. Can you see it, guys? Can you see it? So the zero has come down a little bit. This is 1 unit. Every time I move it, how much is it translating? Just think about it. One sound will come. Actually, I don't have a micrometer screw gauge. If you have held it, every time you move it, tuck, 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 one sound will come. Okay, one tick is one division on the circular scale. I keep tuck 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 like that, sound will come. And if I move it 50 times, I will move by a millimeter. If I move 50 times, I will move by a millimeter. So can you now think and tell me? Feeling the vibe of the mechanical wing. Yes, very true. So now can you think and tell me how much distance will this sleeve move when I get one tick sound, tick, 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 tick sound? How much will it move? Well, think about it. For one rotation, it moves by 1 millimeter or one main scale division, basically the pitch. So for one rotation, it is the pitch. So for one tick or once, if I go from one division to next division of the circular scale, it will be the pitch divided by the number of divisions on the circular scale. So if this was 1 millimeter, divide it 50 times. Divide it 50 times. Is that making sense? Very good. Excellent, JV. Yeah. So if I move it 50 times, then I'm moving 1 millimeter. So each tick is 1/50th of a millimeter. Imagine the circular scale had 100 divisions. One tick, 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 tick will be 1/100th of that particular pitch. So each pitch moves by some millimeters. So one tick or one division on the circular scale corresponds to the pitch divided by the circular scale divisions. So hence the least count formula is nothing but whatever pitch you get, the whole thing divided by the circular scale divisions. So CSD, what is CSD? CSD is basically circular scale divisions. Circular scale divisions. It is basically the total divisions on the circular scale. On the circular scale. If you know these formulas, you are done and dusted. That's it. So what is the pitch? This is very simple. Least count is pitch by CSD. That's it. Let's do some questions based on this. Look over here, guys. You can see one more example over here. Yeah, beautiful example. It's rotating. Yeah, so maybe there are some circular scale divisions. These are your main scale divisions. This is a real micrometer screw gauge. Okay, so let's do this. The least count of the main scale of a screw gauge is 1 millimeter. The minimum number of divisions on the circular scale required to measure 5 micrometer diameter of the wire is the minimum number of divisions. So basically, we want 5 micrometer to be the least count on the least count of the device. Least count of the device. Somehow I want to measure 5 micrometers. That is the smallest length which should be measurable. So that is the least count. And I know that the least count on the main scale is 1 millimeter, meaning this is one main scale division. This is basically the main scale division. Okay. The minimum number of divisions on the circular scale required is how much? Well, let's see whatever formulas we know. Least count is basically the pitch divided by the circular scale divisions. The circular scale divisions. Okay. Now think, guys, whatever that circular scale is, this is your circular scale. If you rotate it once, one rotation, it will move how much? It will go from one division to the next division. It will go from one division to the next division on the main scale. This was your main scale. This is your main scale. And a main scale division length is exactly 1 millimeter. So one rotation makes it go 1 millimeter. Means what? The pitch is exactly a millimeter. The pitch is basically a millimeter. Everybody confirms this? Yeah. One division on the main scale is basically 1 millimeter. So if I rotate it once, I'm going from one division to next division on the main scale. So one rotation is 1 millimeter, which is exactly the meaning of a pitch. How much does it move if you rotate it once? So I know the pitch. I think I know the least count. Our job is done. So pitch is a millimeter. Least count is 5 micrometers. So that is basically 5 into 10 to the power minus 6 meters, whole thing divided by circular scale divisions. So CSD will be 1 millimeter is 10 to the power minus 3 meters. Take this below, 5 into 10 to the power minus 6 meters. Meters cancels, minus 6 minus 3, that will become 10 to the power 3 divided by 5. That is 1000 divided by 5. So therefore, the number of circular scale divisions will be nothing but 200. So 200 is the right answer. Is this clear? How did we do this? These are some elementary questions on just circular scale or least count calculations. Very good, Vijaya. Yes, Precious. Yes, Shravya. Yeah. How do they make this? That's a whole subject in itself. That's a separate branch in itself. You can do specializations on just instrumentation. Yeah. Not electronics and instrumentation. That is a separate thing. But just instrumentation itself is separate thing. Yeah. All right. Now, how do we exactly make a reading on the micrometer screw gauge? The formula is just like before. So the reading of a micrometer screw gauge is, first of all, you have main scale reading. This is our main scale. You check the main scale plus main scale reading. Main scale reading. So whenever you measure main scale reading, it is the division on the main scale which is just crossed, by the circular scale. So the circular scale would have crossed some line. So that is your main scale reading. This one over here. Okay. So that is your main scale reading. Plus, obviously, again, the least count multiplied by the circular scale reading. CSR. This is nothing but circular scale reading. Circular scale reading. Meaning, on the circular scale, which is coinciding on the main scale. You can see on the circular scale, this is 35, this is 36, 37, 38. So 38 is the circular scale reading over here. Can you understand it? Why it is 38? Because this line exactly matches with the main scale. Not that main scale, this line over here. Because 0 otherwise should have been here. Now 38th line is coinciding. So that is your circular scale reading. And of course, minus the 0 error. Here also you have 0 errors. Minus the 0 error. Okay, you can again have positive 0 error, negative 0 error. Both kinds of 0 error are possible. And if it is a perfect instrument, the 0 error itself will be 0. We'll see what 0 error looks like, okay, in a bit. So 0 errors are possible, positive or even negative, or no 0 error. So let's understand this by looking at it practically. Okay, let's take the number of divisions to be little bit less over here. All right, and what I have done over here is there are only 25 divisions, as you can see, 0, 5, 10, 15, 20, 25. 25 is resetting it back to 0. 25 is resetting it back to 0. Okay, so let me just move it something randomly and see what should be the reading over here. Okay, just what should be the reading over here. All right, now, first of all, let's calculate the least count of this device. Before getting the least count, we cannot proceed ahead. So let's find out what is the least count. So for that, what is the pitch? What is the pitch? So when I rotate it once, it is moving by a millimeter. So the pitch is 1 millimeter in this case. The number of circular scale divisions is basically 25. As you can see, there are 25 divisions. So the least count, which is basically the pitch divided by circular scale divisions, will be 1 millimeter by 25. Okay, so this is the least count, 1 by 25. Keep it aside. Now, let us see what is the main scale reading, circular scale reading, everything. What is the main scale reading? So it is that division which is clearly visible and which has been just crossed by the circular scale. This is 1, 2, 3. So main scale reading is basically 3 millimeters. What is the circular scale reading? Circular scale reading. Come on guys, everyone. Yeah. This is for mains and advanced both, JV08. Yeah. So check this, 0, 1, 2, 3. What is it guys? 0. I think it is the third one, 1, 2 and 3. So it is basically 3 by coincidence, just by coincidence. All right. So let us write down the final answer. The reading will be, so our final reading means whatever is this length. This reading will be main scale reading, which is 3 millimeters, plus least count, which is 1 by 25th of a millimeter, multiplied by circular scale reading, which is 3. So this will be 3 and 1 plus 1 by 25, 1 plus 1 by 25, which is 3 multiplied by 25 plus 1 is basically 26 by 25. Is that right? So 1 plus 1 by 25 is basically 26 by 25. 26 into 3. How much is it, guys? 26 into 3. That's going to be 78. So 78 by 25 millimeters. 78 by 25 millimeters. If you want, you can write it in decimals also. Yeah, but we have put it in fraction. How many of you got it, guys? Everybody clear about this? Everyone? Yes or no? Got it? Perfect. Yes, 78 by 25. If you want to write it in decimal, how much will it be? If you want to write it in decimals, how much will it be? Come on, do the math. 3.12 millimeters. Just check this out. 3.12. Yes, 3.12 millimeters. Perfect. Amazing. Yeah. So this is the answer. So this is how you measure a micrometer screw gauge. All right. So now that you have understood how to measure a micrometer screw gauge, what is the meaning of the zero error over here? Okay, let's take a zero error over here, something like this, some value. Okay. Now, if I move it back to zero, that means the jaws, the spindle is touching the anvil. This is the spindle, this is the anvil. If I completely touch it, traditionally it should have shown 0, 0, but it is not showing 0, 0. Oh, meaning there is a problem over here. Okay, let's say how much is the zero error in this scenario. Let's start completely from the basics again. Okay, what is the pitch and everything? Let's start completely from the basics, guys. So the pitch again is a millimeter, but the circular scale divisions, I have chosen the circular scale divisions as 50. I can adjust. If you move this, no, you can see it also. I unfortunately cannot move it now. So it is basically 50. So the least count will be 1 millimeter divided by 50. 1 millimeter divided by 50. Okay, fair enough. So what is the zero error? For that, we need to calculate the first thing, main scale reading. I have just crossed 0, so 0 millimeters. Circular scale reading. What is it? This is 10, 11, 12. It is basically 12. So our zero error. So our zero error will be, in fact, it will be positive 100%. So it will be 0 main scale reading plus least count, which is 1 millimeter by 50 multiplied by circular scale reading, which is 12. So how much is it coming out to be? Zero error, zero error, zero error. How much is it coming out to be? It is just coming out to be 12 by 50th of a millimeter. So this is the positive zero error, 12 by 50 of a millimeter. Everyone with me on this? Yes, perfect. Very good. Hi, Shiva. Yeah, great, great, great. Yeah, Precious already told it. Yes, 12 by 50 is nothing but your 0.24 millimeter. So this is extra. So say for example, when you place the object with the object, you get the answer as 7 point, let's say 48, or let's say 7 point something like 7 point, or let's say 9.72 millimeters. Chumma, I put some answer. What will be the actual, what will be the actual length? What will be the actual length? It won't be 9.72. It will be, subtract the zero error, which is 0.24. Yes, how much is it going to come out to be? Yes, 9.72 minus 9.72 minus 0.24, guys. Perfect. Very good, yeah. 9.48 millimeters. Wow, very fast. Very fast, Precious. Very good. Very good. Proud of all of you. So this is how you solve the questions. If it is a positive error, you will subtract it. Even if it is a negative error, you will still subtract it, because negative will add. So technically you are adding, but we say that zero error has to be subtracted so that there is no confusion at all. Okay. 2025 passed out student just came to watch you, sir. Missing your classes. Pranav, wow. Thank you so much for the hearts and that fire emoji. And nice to see my 2025 class warriors graduating. And Pranav, yes, I remember you. I'm pretty sure next couple of months you won't remember any of us, because you will be fully engrossed with your new friends, new teachers, new institute. Enjoy your college life, right? So have a great time in college. And if at all sometime you remember us, please do come and say hello to all your juniors. Motivate all of them, right? Cool. So let's begin. Let's begin to the next question. Okay. So zero error means zero will coincide here. Positive means it will go on the sorry, it will that zero on the circular scale will be below. It will already show some reading. Negative error means it will be like this. It will be like this. Yeah, it will be like this. So be careful. Yeah, be little bit careful. Right. Just very curious over here. Can you guys quickly tell me if it is like this, what is the zero error? What is the zero error in this case? Yeah, directly read it now. Yeah, I mean, just look at it 10, 11, 12. So let's say it is like this. It is basically, okay, sorry, I have to touch it. So over here, can you see it is basically the 12th reading? It is basically the 12th reading. Yeah, 12th reading on the circular scale. But remember, okay, but remember, technically the zero should have been here. You had to travel like this. So the counting is happening reverse. So actually the main scale reading is not zero, it is -1. Yeah, main scale reading is -1. Be careful. Don't take the main scale reading as zero. The main scale reading is -1. -1 line should be here. And yes, this is the 12th reading on the circular scale. So you can just do the simple math then in this particular scenario. It is nothing but what is it? The main scale reading is -1 millimeter. Circular scale reading is how much? It is basically 12. So the zero error will be -1 millimeter plus the least count. I think the least count was 1 by 50 if I'm not wrong into 12. So that's how it will be. So it will be 12 by 50 minus 1, which is nothing but negative 38 by 50th of a millimeter. Negative 38 by 50th of a millimeter. That's how it is. Yeah, cool. So after this, I'm pretty sure you will not have any issues. Yeah. So only for the negative errors, be little careful. The readings have to be taken from the previous left side value, main scale. Yeah. So keep that particular thing in mind. Lot of students make that mistake over there. Okay. Let's solve a question from 2022 JEE Shift 1 question. Screw gauge moves, very different question, 0.5 or main scale in one complete rotation. From this 100% I got to know the pitch. So for one rotation, it is moving 0.5 millimeters. Means the pitch is how much? It is 0.5 millimeters. Okay. Total divisions on the circular scale already mentioned, it is 50. So this is basically CSD. From this, I can easily get the least count, which is pitch 0.5 millimeters divided by circular scale divisions, which is 50, which is 0.01 millimeters. That is the least count. Okay. Next, we got the main scale reading. This is basically MSR. 45th division of circular scale is in the pitch line. Oh, we got the circular scale reading also. Instrument has negative zero error. So zero error also we know. So now let's write down what is the final value. Final diameter of that wire is. It is main scale reading plus least count multiplied by circular scale reading minus the zero error. Okay. What is the main scale reading? Main scale reading is 2.5 millimeter. Least count is 0.01 millimeter multiplied by circular scale reading. Circular scale reading 45th. 45th division is the circular scale reading minus the zero error. Zero error is negative. So it is minus 0.03 millimeter. This is what the calculation will look like. So it will be 2.5 millimeters plus 0.01 into 45, that is 0.45 millimeters. Minus minus will make it plus 0.03 millimeters. So that will be my final answer. How much is it coming out to be? 8 will be there over here. 5 plus 4 will be 9 and 2. So 2.98 millimeters, which is option C, I believe. Yes, it is the answer, my dear warriors. 2.98 millimeters. Yes, very good, Precious. Yes, Abhijit, perfecto. Very good, Shipali. Very nice. Just trust this guy. Thank you. Thank you so much, Pranav, for those words. Yes, perfect, perfect. So to master problem solving, start with easy, conceptual, build it up, solve many questions. Don't jump to advanced, don't jump to Verodo directly. Solve many such questions, understand the concept, see why you're doing it, reason it out. And if you are convinced with the why part in the initial stages, then it just becomes like a ready-made result in your head. Okay, if this happens, then this you have to do. Because you have reasoned it out several number of times at home, then you don't have to think through the same process again. So you're directly going a step above. You're going for higher level concepts. So to master higher level concepts, the lower level concepts should be convinced for you. And if anything is not matching, or if something is unconventional, or something is very different, you know how to think from the basics. That's what JEE Advanced is all about. The basic concepts only will be challenged. You'll have to think from the ground root. Yeah. Okay, this only is not valid. This formula only is not valid. So how do I go with this? How do I solve it in such a scenario? So that is what you need to master at the end of the day. All right. Perfect, my dear warriors. So that was the final question on your screen. And I hope you guys enjoyed. Oh, we have to give a homework and I missed that homework question. This is our homework question. Yes, right over here. So please solve this. Homework answer should be in the there in the comment section. Yeah, please put it in the comment section. Just like I read today's comment, same way I will read it the comments in the next class. Shall we start vectors next class then? Ready for vectors? Okay. So let's begin. All right, next slide. So the answer is there on the next slide. PDF will be there in the description box. And if you've forgotten to smash the like button, please smash the like button right away, right now. These are the most detailed and engaging classes that you can ever get from me on YouTube. So make sure you're a part of this. And if you're loving the way I teach and the way we teach at Vedantu, you have so many options, my dear warriors, to be a part of the system. One option is you can join our pro batches. These batches have offline like discipline. It makes you feel that as if you are sitting in an offline lecture, but on the front bench. You have a dedicated proctor who is monitoring you and your attendance, helping you maintain that discipline. Secondly, you have a personal teacher even after the class, not just for doubt solving, but even for non-academic queries. You have parent-teacher meetings, you have dedicated doubt support, you have 24/7 doubt support, in fact, in the class, outside the class. You get the coaching modules, regular class tests, final revisions, and more revisions, whether it is mains, whether it is advanced. And based on your performance, we help you to improve your performance. See, some students will do very well, will help you perform even better, will train you for Olympiads also. Sir, I'm not getting basic score also. My boards also is a problem. Don't worry. We will make sure that our personal teachers and mentors train you for that board exam also. So this is the kind of dedicated support that you get, because in a traditional classroom, what happens? Everyone gets the same learnings, but here you get a personal guide, a personal mentor. So check out this free demo. The link is there in the description box. Mention your name, your mobile, grade, etc., what language you want. Our pro batches are in English too, and you can join our pro batches. But if you're lucky enough to have any of the Vedantu learning centers around you, you can go visit any of the Vedantu learning centers. Yeah, you can check out the links are there in the description box, Vedantu Offline Learning Center. But yes, many people prefer online, and the results that I showed you were through online exclusively, means that you are saving time, money, and energy. So if you like that online experience, go ahead with it. Okay, because we have a proven track record of getting those results. Thank you so much. Have a great time and a lovely evening. See you for the next chapter. Bye bye. Captain Shreyas signing off.